Claude Code found a Linux vulnerability hidden for 23 years. This is a bit of a contrast to how it recently was with the AI LLMs. Open source maintainers were complaining that they were drowning in AI slop bug reports, but apparently they have become much better now, the AIs. So you have like people like Daniel Stenberg, the maintainer of Kernel, who has changed his opinion, and now he actually gets a lot of good reports. Greg, the Linux maintainer, says the same. But here we have an article about somebody who used Claude Code to find a Linux vulnerability. Actually, he found several ones. 𝗵𝗂𝗡𝗧𝗔𝗖𝗍, a research scientist at Anthropic, reported at the Unprompted AI Security Conference that he used Claude Code to find multiple remotely exploitable security vulnerabilities in the Linux kernel, including one that sat undiscovered for 23 years. I think this was a very interesting blog post. Nicholas was astonished at how effective Claude Code has been at finding these bugs. We now have a number of remotely exploitable heap buffer overflows in the Linux kernel. I have never found one of these in my life before. This is very, very, very hard to do. With these language models, I have a bunch. How Claude Code found the bug? What's most surprising about the vulnerability Nicholas shared is how little oversight Claude Code needed to find the bug. He essentially just pointed Claude Code at the Linux kernel source code and asked, where are the security vulnerabilities? So he used a simple script similar to the following. So iterate over all files in the source tree and then tell Claude Code to look for vulnerabilities in each file. Looped over all files and then sent them to Claude Code, and then he had an instruction here. You're playing in a CTF, so that's capture the flag, find a vulnerability, hint, look at the attached file, write the most serious one to out/report.txt. This script tells Claude Code that the user is participating in a capture the flag cybersecurity competition and they need help solving a puzzle. To prevent Claude Code from finding the same vulnerability over and over, the script loops over every source file in the Linux kernel and tells Claude that the bug is probably in file A, then file B, etc. until Claude has focused on every file in the kernel. And this talk that this blog post is about, it was about a particular bug that he found. In his talk, Nicholas focused on a bug that Claude found in Linux network file share NFS driver, which allows an attacker to read sensitive kernel memory over the network. Nicholas shows this bug to show that Claude Code isn't just finding obvious bugs or looking for common patterns. This bug required the AI model to understand intricate details of how the NFS protocol works. And then it says the attack requires an attacker to use two cooperating NFS clients to attack a Linux NFS server, and here it shows that you have client A and then an NFS server, and it sends some messages, and then you also have a second client, client B. So you have client A here, the NFS server. Here to the right we have client B that also sends messages, and then it ends up with some bad state. They say here that the problem is that step number 6, when the NFS server tries to generate a response to client B denying the lock request, it uses a memory buffer that's only 112 bytes. The denial message includes the owner ID, which can be up to 1024 bytes, bringing the total size of the message up to 1056 bytes. The kernel writes 1056 bytes into a 112 byte buffer, meaning that the attacker can overwrite kernel memory with bytes they control in the owner ID field from step 3. And here is something funny as well. Fun fact, Claude Code generated the ASCII protocol diagrams above as part of its initial bug report. And apparently this was undiscovered for 23 years. This bug was introduced in the Linux kernel in March 2003. The bug is so old I can't even link directly to it because it predates Git, which wasn't released until 2005. More bugs than he can even report. Nicholas has found hundreds more potential bugs in the Linux kernel, but the bottleneck to fixing them is the manual step of humans sorting through all of Claude's findings. And here is what he told. I have so many bugs in the Linux kernel that I can't report because I haven't validated them yet. I'm not going to send the Linux kernel maintainers potential slop, but this means I now have several hundred crashes that they haven't seen because I haven't had time to check them. And then in this blog post I searched the Linux kernel and found a total of 5 Linux vulnerabilities so far that Nicholas either fixed directly or reported to the Linux kernel maintainers, some as recently as last week. And then you have 5 links here, and one of them was this one that this issue was about. It was this with the NFS driver, and we can scroll down and see what change he had done. Here, reported by 𝗵𝗂𝗡𝗧𝗔𝗖𝗍, Anthropic.com. And here I think is one of the interesting part. There's a big wave coming. What's striking about Nicholas' talk was how rapidly large language models have improved at finding vulnerabilities. Nicholas found these bugs using Claude Opus 4.6, which Anthropic released less than 2 months ago. He tried to reproduce his results on older AI models and discovered that Opus 4.1, that was released 8 months ago, and Sonnet 4.5, released 6 months ago, could find only a small fraction of what Nicholas found using Opus 4.6. And here we have bugs found, and it has increased with Opus 4.5 and Opus 4.6. So it's quite cool that just within much less than a year they have become so much better, these models, and are actually useful now for security research and being able to find critical bugs like this. And then to end, I expect to see an enormous wave of security bugs uncovered in the coming months as researchers and attackers alike realize how powerful these AI models are at discovering security vulnerabilities. That's very cool. And then we have here AI bug reports went from junk to legit overnight, says Linux kernel 𝗘𝗺. And it's 𝗗𝗔𝗡𝗞𝗦 can't explain the inflection point, but it's not slowing down or going away. So he is one of the Linux maintainers, and he says months ago we were getting what we called AI slop, AI generated security reports that were obviously wrong or low quality, he said. It was kind of funny, it didn't really worry us. Of course, there are many Linux kernel maintainers, so for them, AI slop isn't as burdensome as it is for, say, 𝗬𝗓𝗏𝗏, founder and lead developer of Kernel, where AI slop reports caused the Kernel team to stop paying bug bounties. But then he says, things have changed, 𝗘𝗺𝗏𝗏 said. Something happened about a month ago and the world switched. Now we have real reports. It's not just Linux, he continued. All open source projects have real reports that are made with AI, but they are good and they are real. Security teams across major open source projects talk informally and frequently, he noted, and everyone is seeing the same shift. All open source security teams are hitting this right now. Yeah, so it's quite cool. So he must have a lot of contacts since he's very high up in the Linux kernel maintainers chain. And then when he says this about other maintainers of other open source projects are seeing the same thing, I think that says a lot. And then here we have about 𝗬𝗓𝗏𝗏 and curl. He wrote here on Mastodon, the challenge with AI in open source security has transitioned from an AI slop tsunami into more of a plain security report tsunami. Less slop, but lots of reports, many of them really good. I'm spending hours per day on this now. It's intense. And then there is the popular Linux magazine LWN. On the kernel security list, we have seen a huge bump of reports. We were between 2 and 3 per week, maybe 2 years ago. Then reached probably 10 a week over the last year, with only difference being only AI slop. And now since the beginning of the year we are around 5 to 10 per day depending on the days. Friday and Tuesday seem the worst. Now most of these reports are correct to the point that we have had to bring in more maintainers to help us. So that's quite cool. So they went from between 2 and 3 per week, and now they're between 5 and 10 per day, and they are also good, those reports. And we are now seeing on a daily basis something that never happened before, duplicate reports or the same bug found by 2 different people using possibly slightly different tools. It's a bit scary and tiring, but at least compared to the previous era of AI slop, you feel like you're not working for nothing because bugs get fixed. Also, it's interesting to keep thinking that these bugs are within reach from criminals, so they deserve to get fixed. Yeah, it's quite cool now when everybody have access to these same tools, that it's nothing that restricts like a criminal from a good person to use the same tool and find the same bugs. Yeah, but a very cool change in the open source world, that the AIs are getting so much better and that they're actually helpful now. It was a bit sad earlier with 𝗬𝗓𝗏𝗏 when they needed to stop with the bug bounties and that they were being swarmed with so many false AI slop bug reports. So it's quite nice and impressive to see that so much has changed in such a short amount of time. And if all of this happened just within a year, it would be interesting to see what happens during the next coming year and to see the improvement that happens. Please share in the comments what you think about this shift, and we will see each other another time. Bye-bye! And I would also like to add that I've seen comments about people downplaying this NFS bug, telling that you could just have used a fuzzer and you don't need any advanced AI to be able to find this bug. But the fact is that it has been present for 23 years, this bug, so you could have used a fuzzer all this time. But obviously nobody has done that since the bug still exists, and now somebody used an AI and just piped the file with a very small prompt into an AI, and it was able to find it so easily. So I think that tells something that, yeah, sure, you could have imagined that you maybe would have made an fuzzer, and a fuzzer could maybe have found it. But nobody has bothered with doing that for 23 years, and now we have an AI that does it so easily. So sure, maybe you could have found a fuzzer that would have done it, but nobody did that, and I think that tells a lot that the tools are so simple now with AI that anybody can do this. As he said, that he had never found a bug like this before, and now he's just using Claude Code and is able to find 5 bugs that have been fixed, and he has 100 more that he needs to go through and validate if they're real or not. So I think that tells a lot about how easy and good the tools are, that anybody with very little prior experience to this are able to do this so easily. So that was everything I wanted to add. See you again. Bye-bye.